Hi there, you're in the lab with your mate JJ. Today is cheat sheet day. Silly job title for today is tone pumper. Today I'm the tone pumper. And on cheat sheet day, we go through a cheat sheet and learn about a whole subject. Most of them are quick study academic cheat sheets. They call themselves the world's #1 academic outline. The one that we'll be looking at today is for elementary algebra. This is the second one that we're doing. We've already done pre-algebra. We did that recently. I try to get a cheat sheet done on Sundays. So today is Sunday and today is cheat sheet day. Now, in the future, we'll be doing some other types of cheat sheets too, which is why this section's not simply called quick study. Most of the things that we do will be quick study, but I'm open to having other cheat sheets available. If anyone has a recommendation, please let me know. I also intend to go through the VisiBone cheat sheet book as well. This is what they call the everything book, and we'll go through it part by part. It's got sections on colors, fonts, HTML tags, CSS styles, JavaScript primer. Of course, it's a bit old now. I mean, it'll still be relevant, but it's a bit old. The DOM, such as it was, it's still got notes about compatibility for Internet Explorer and such, which no one cares about anymore. It was very useful back in the day when that sort of stuff mattered. We've got a section on regular expressions, and some client-side stuff, some server-side stuff in PHP, and then there's a function reference for PHP functions, and then that's a pretty vast, and then it's got stuff for MySQL for functions and tables and this sort of thing, and then it's got functions for MySQL as well. So that's the VisiBone everything book. You can't get them anymore, I don't believe. That he's not manufacturing them. But it was a really handy primer. It continues to be if you just want a quick brush up on your web technology. Anyway, that's why I called it cheat sheet, because it's not limited to the quick study stuff, but it is mostly going to be that. And I'm working through them in the order that they come up in the documentation. They're roughly, I chose the order, but I tried to make it sensible so that we cover earlier topics before we take on later topics. So I'll throw over to the computer and I'll just show you my notes. Then we'll jump over to the bench and we'll go through the quick study guide.
All right. Well, here we are on the computer. We're at the ITL wiki, which is, of course, the wiki for the show. It's in the lab with jj.com/wiki. That's where you'll find this. Some of the content on the wiki is subscriber-only content, but the the quick study stuff is actually, I'm just going to change that quickly. I did name the project Quick Study, but I'm going to rename it as Cheat Sheet. Is it cheat sheet or cheat sheets? I'm not sure. Yeah, Cheat Sheet. Cool. So this is the one we'll be doing today, is elementary algebra. You should be able to access this if you're interested. It's on the web at inthelabwithjj.com/wiki/cheatsheet. And if you want to go through that, you're more than welcome to have a look. The links go to Amazon, except if I've already recorded the video, in which case they go to the show notes for the video. So this pre-algebra will load up the page, and if you want to get through to Amazon, just click on the link there. That's a link to Amazon through the show notes. And of course, as I said, today we'll be doing elementary algebra, where topics are broken into mathematics, science, engineering, programming, Excel, finance, and writing. So we'll be covering cheat sheets, quick study cheat sheets in all of those topics. The one that we're doing today is elementary algebra. So let's pop over to the bench and have a look at it.
Here we are on the bench. This is our academic quick study. academic outline. You can see it's a fold out, so it's got 1, 2, 3, 4, 5, 6 pages. We'll be going through all of them in order. So let's begin. Let's put that there. How's that? You can see that? Great. So, integers. Integer. Set of positive and negative whole numbers including 0. The set of integers is ... -3, -2, -1, 0, 1, 2, 3, ... Compare integers. Integers can be compared using a number line. Horizontal number line. The number furthest to the left is the lesser integer, and the number furthest to the right is the greater integer. Vertical number line. The number furthest to the bottom is the lesser integer, and the number furthest to the top is the greater integer. For example, compare -3 and -5 using less than, greater than, less than, or equal to. Plot -3 and -5 on a number line. -3 is greater than -5. -3 is further to the right than -5 on the number line, so -3 is the greater integer. In this example, -5 is further to the left than -3 on the number line, so -5 is the lesser integer. Another way to compare these numbers is -5 is less than -3. For example, compare this is another example, separate to the example we just did. Example, compare -4 and -1 using greater than, less than, or equal to. Plot -4 and -1 on a number line. -4 is less than -1. -4 is further to the bottom than -1 on the number line, so -4 is the lesser integer. In this example, -1 is further to the top than -4 on the number line, so -1 is the greater integer. Another way to compare these numbers is -1 is greater than -4. Order integers. Integers can be ordered using a number line. When ordering numbers from least to greatest on a horizontal number line, list the numbers in order from left to right. When ordering integers from greatest to least on a horizontal number line, list the numbers in order from right to left. Then there's an example. Order the integers -4, 0, 3, -2, and 1 from least to greatest. And then they've given us the plot on the horizontal number line, and we start with -4, go to -2, go to 0 to 1, and then to 3. As they say here, -4, -2, 0, 1, 3. List the numbers in order from left to right. And there's another example here of ordering the integers -5, -1, 5, 4, and 2 from greatest to least. Plot them on the number line, -5, -1, 2, 4, and 5, and then they come out ordered in greatest to least, 5, 4, 2, -1, and -5. Absolute value. The absolute value of a number is the distance from 0 on a number line. Distance is positive, so the absolute value of a number is always positive. Vertical bars are used to denote absolute value. For example, simplify the absolute value of 37 is 37. Absolute value is always positive. Simplify the absolute value of 25, it's 25. Absolute value is always positive. And to simplify 10 minus 12, you get -2, and the absolute value of -2 is 2, so the absolute value of 10 minus 12 is 2. Integers can be compared without using a number line. A positive number is always greater than a negative number. When both numbers are positive, compare the absolute value of each number. The number with the greater absolute value is the greater number. When both numbers are negative, compare the absolute value of each number.
the number with the greater absolute value is the lesser number. For example, compare 24 and minus 43 using greater than, less than, or equal to. A positive number is always greater than a negative number, so 24 is greater than minus 43. Another example, compare 15 and 21 using greater than, less than, or equal to. Both numbers are positive, so compare the absolute value of each number. 15 is absolute value of 15 is 15, absolute value of 21 is 21. 21 is greater than 15, so and also it's 15 is less than 21. Compare minus 16 and minus 23 using greater than, less than, or equal to. Both numbers are negative, so compare the absolute value of each number. Absolute value of minus 16 is 16, absolute value of minus 23 is 23, and minus 23 is less than minus 16, and minus 16 is greater than negative 23. Exponents. The number 5 to the power of 2 has a base of 5 and exponent of 2. The exponent tells you how many times to multiply the base by itself. For example, simplify 6 squared. 6 squared equals 6 times 6. The exponent of 2 means multiply the base of 6 by itself 2 times. And 6 times 6 is 36. So that's the result of 6 squared. The second example, simplify minus 4 cubed. So minus 4 cubed is minus 4 times minus 4 times minus 4. The exponent of 3 means multiply the base of minus 4 by itself 3 times. And minus 4 cubed equals minus 4 times minus 4 times minus 4 equals minus 64. Order of operations. A set of steps to follow to perform operations. 1. Simplify inside parentheses. 2. Simplify exponents. 3. Multiply and divide from left to right. 4. Add and subtract from left to right. For example, simplify 5 plus open bracket 3 minus 2 close bracket times 2 to the power of 3. So first we simplify inside the parentheses and we get a new expression, which is 5 plus 1 times 2 cubed. Then we simplify the exponents, so that's 2 cubed is 8. Then we multiply, which means that we do our 1 times 8, which becomes 8, and then we do our addition, which is 5 and 18, and this result is 13. And there's another example here. This is simplify 16 divided by open bracket 2 squared times 4 close bracket minus open bracket 3 squared plus 1 close bracket squared. So okay, so that's interesting. So simplify exponents inside parentheses, then simplify inside parentheses, then simplify exponents, then divide, then subtract, and the result is minus 99. All right. So on we go, page 2. This is expressions, equations, and inequalities. Types of expressions. Numerical expression contains numbers and operation symbols such as 5 times 8 or 3 plus 4. Algebraic expressions contain numbers and at least one variable along with an operation with operation symbols such as a minus 6 or 7x divided by 32. For example, are the expressions numerical or algebraic? Explain. So the example A is 5 minus 6 squared. I'll be back in a sec. Just got myself a coffee and now I'm back. So let's go from the top. Types of expressions. Numerical expression contains numbers and operations. Algebraic expression contains numbers and at least one variable along with operation symbols such as a minus 6 or 7x divided by 32. Example, are the expressions numerical or algebraic? Explain. So 5 minus 6 squared is numerical. There is no
Well, the expression 5 minus 6 squared contains numbers and operation symbols, so it's a numerical expression. And B, 6a plus 2b plus 1. The expression 6a plus 2b plus 1 contains numbers, variables, and operation system symbols, so it is an algebraic expression. Yeah, right. I think I don't know. Does it have to have a variable to be an algebraic expression? Maybe you could say it's a type of algebraic expression. I don't know. Okay, algebra seems to suggest that algebraic expression has to have a variable. That's according to this. I don't know if that's true. Numeric expression. I don't know. You can use numerical expressions in algebra, but fair enough. So translating expressions. A verbal description can be translated into an expression. Use keywords to help you. Okay, so words for addition, sum, altogether, plus, increased by. Words for subtraction, difference, fewer, minus, decreased by. Multiplication, times, product, multiplied by, multiple. Division, shared equally, quotient, divided by, average. That's interesting. For example, translate each verbal expression into an algebraic expression. So the example A, 13 minus 3 times x. So that's 13 minus 3 times x, and it's written as 13 minus 3 times x. And the second example, the time t increased by the distance squared. So the time t increased by the distance squared. This is t plus d squared. Simplifying expressions with like terms. Like terms have the same variable with the same exponent. For example, 5a cubed and minus 2a cubed are like terms because both terms have the same variable a with the same exponent 3. To combine like terms, group coefficients of like terms, then combine the coefficients. For example, 5a cubed minus 2a cubed equals 5 minus 2a cubed equals minus 3a cubed. Another example, simplify 4x plus 2x squared minus 12x plus 11x squared by combining like terms. So first you group like terms with parentheses, then group coefficients of like terms, as you can see, and then combine the coefficients of like terms. There you go. And there's another example here. Simplify minus 3y squared minus 8y cubed plus 5y cubed minus 2y squared plus 3y by combining like terms. So first we group like terms with parentheses, then we group coefficients of like terms, and then we combine the coefficients of like terms. Linear equations. It's got a little sidebar here. It says equation is a mathematical statement equating two expressions. Solving linear equations. To solve an equation for a variable, use properties of equality where a, b, and c are real numbers. Properties of equality. Addition property. If a equals b, then a plus c equals b plus c. Subtraction property. If a equals b, then a minus c equals b minus c. The multiplication property. If a equals b, then a times c equals b times c. And the division property. If a equals b, then a divided by c equals b divided by c. And that what it should say there, and c doesn't equal 0. Okay, example. Solve the equation x minus 8 equals 15 for x. So the original equation is x minus 8 equals 15. I use the addition property to say that x minus 8 plus 8 equals 15 plus 8. And then we simplify that and we get x plus 0 equals 23. So x is 23. Solve the equation x plus 20 equals 32 for x. So we've got x plus 20 equals 32. We subtract 20 from both sides, and we simplify and we get x equals 12. To solve the equation x divided by 6 equals minus 2 for x, we start with x on 6 equals minus 2. We multiply both sides by 6, and then we get x equals minus 12 after simplifying. And then we've got up the back here, we've got solve the equation 5x equals 35 for x. So we divide both sides by 5 and we simplify and we get x equals 7. To solve the equation 4x minus 2 equals 14 by x, we start with the original equation with 4x minus 2 equals 14. We use the addition property to add 2 to both sides and we get 4x equals 16, and then we divide both sides by 4 and we get x equals 4. Literal equations. Literal equation is an equation where the constants are represented by letters. Okay, for example, wx plus y equals z is a literal equation where x is the variable and w, y, and z are the constants. Okay, that's a bit odd. Literal equations can be solved for the variable using properties of equality. For example, solve the literal equation ax minus b equals c for x. Okay, so the original equation is ax minus b equals c. Then we use the addition property to add b to both sides, and we simplify. And then we divide both sides by a, and then we simplify. So x equals c plus b divided by a. Okay. Solve the literal equation x divided by m plus n equals q for x. So first we subtract n from both sides, and then we multiply both sides by n, and we get a result which you can express in two ways. It's m outside of q minus n. Also, it could be written as mq minus mn. Linear inequalities. Inequality, a mathematical statement between two expressions using the symbols greater than or equal to, less than or equal to. Solving linear inequalities. To solve an inequality for a variable, use properties of inequality where a, b, and c are real numbers. When multiplying or dividing by a negative number, the inequality symbol is flipped. Okay, properties of inequality. The addition property. If a is greater than b, then a plus c is greater than b plus c. And if a is less than b, then a plus c is less than b plus c. Subtraction property. If a is greater than b, then a minus c is greater than b minus c. And if a is less than b, then a minus c is less than b minus c. Multiplication property. If c is positive, if a is greater than b, then ac is greater than bc. If a is less than b, then ac is less than bc. If c is negative, if a is greater than b, then ac is less than bc. And if a is less than b, then ac is greater than bc. The division property. If c is positive, then a is greater than b. Sorry, if c is positive, if a is greater than b, then a divided by c is greater than b divided by c. And if a is less than b, then a divided by c is less than b divided by c. If c is negative, if a is greater than b, then a divided by c is less than b divided by c. And if a is less than b, then A divided by C is greater than B divided by C. Note, in this table, greater than can also be greater than or equal to, and less than can also be less than or equal to. Okay, here's the example. Solve the inequality 3x plus 1 is greater than 19 for x. So we start with the original inequality, which is 3x plus 1 is greater than 19. Then we use the subtraction property of inequality. So we subtract minus 1. We subtract 1 from each side, and we simplify, and we get 3x is greater than 18. And then we divide both sides by 3. Using the division property, we get x is greater than 6. Another example, solve the inequality x divided by negative 2 minus 8 is less than or equal to 3 for x. So start with the original inequality, which is x divided by minus 2 minus 8 is less than or equal to 3. We use the addition property of inequality to add 8 to both sides, and we get x divided by minus 2 is less than or equal to 11. And then we multiply both sides by minus 2. And when we multiply by minus 2, we have to flip the inequality symbol, and we get x is greater than or equal to negative 22. So it says here, when multiplying or dividing by a negative number, the inequality symbol is flipped. So because we divided by we multiplied by minus 2, that qualifies as a inequality symbol flip. Great. All right, so on we go up to page 3. What is this page? Relations and functions. Okay, so we're going to define relations. Relation, a set of pairs of input and output values or ordered pairs. For example, consider the sets A equals blue, red, yellow, and B equals shirt, pants. By choosing the first element from set A and the second element from set B, all of the ordered pairs in the following set can be formed. Blue shirt, blue pants, red shirt, red pants, yellow shirt, yellow pants. A relation from set A to set B is any set of those ordered pairs. Finding domain and range. Domain is the set of all the input values or first members of the relation. The range is the set of all output values or second members of the relation. For example, consider the relation given by the list minus 1, 0, 2, 4, 3, 6, 4, 8, 2, 7, 5, 10. What is the domain and range of the relation? The domain is minus 1, 2, 3, 4, 5. And the range is 0, 4, 6, 7, 8, and 10. Note, 2 is listed only one time, even though it is in the input value of 2 ordered pairs. 4 ways, I think actually that a set, even if it includes values, it's not wrong. So it's still a set if it's got multiple values. They just don't affect the set. 4 ways to represent a relation. List of ordered pairs, the same ones that we used earlier. Minus 1, 0, 2, 4, 3, 6, 4, 8, 2, 7, 5, 10. Mapping diagram. A mapping diagram has arrows drawn to pair elements of the domain with elements of the range. The domain on the left pointing to the range on the right. A table with the domain or x values in the first column and the range or y values in the second column. and you can graph. Each ordered pair is graphed as a point on a coordinate plane, also called a Cartesian plane, of course. Identifying functions. A function is a relation in which each element of the domain is paired with exactly one element in the range. Use a mapping diagram. One way to identify whether a relation is a function is to examine the mapping diagram. The 2 in the domain is paired with the 4 and 7 in the range. This relation is not a function, right? Because it can't have multiple y values. And here, each element of the domain is paired with exactly one element of the range. This relation is a function. You can also have all of the domain pointing at the same value, and that would still be a function. So the thing is, you can't have multiple values from the domain to the range. All right, use the vertical line test. Another way to identify whether a relation is a function is to use the vertical line test on the graph of a relation. If a vertical line passes through at least 2 points on a graph, then one element of the domain is paired with more than one element of the range. The relation is not a function. The domain of a function is the set of all possible inputs of the function, and the range of a function is the set of all possible outputs of the function. And so we've got here, we've got the parabola. The parabola is a function. The domain is the set of real numbers, and the range is the set of real numbers greater than or equal to 3. The range that's greater than or equal to -3. That's a mistake. That's supposed to say -3. Should we mark up our, I don't know if I've got a pen that will work on this thing. Hang on a sec. I've got these swank Pigma pens, and they're all different types. Pigma Micron, Pigma Graphic, so they're all different. Let's see what happens if we scribble in a corner with this pen. It rubs right off. I wonder if I've got a pen which will work. I think I do, but they're too big. I won't be able to fit a negative sign anywhere there. Anyway, it's not important. We know. So the range is the y values, and when the parabola comes down to -3, then that's the y value. So the y values are greater than, or that's just wrong. Anyway, we won't bang on about it. And here is a circle. This is what a circle looks like. And it's not a function because each point on the x-axis has 2 points on the y-axis, except at the extremes, of course, where they're the same. Okay, function notation. Functions are often named by letters. Functions are often named by letters. Since a function is a relation, a function f is a set of ordered pairs. Represent the first coordinate of an ordered pair by x and the second coordinate by f of x. The ordered pair is x fx. The symbol fx is read f of x. The number represented by f of x is the value of the function at x. For example, f of x equals 3x plus 1, where f is the name of the function, x is the input, and 3x plus 1 is the rule. The function is read f of x equals 3 times x plus 1. Functions. To evaluate a function f of x at x, substitute a value for x, then simplify.
For example, given the linear function f of x equals 2x minus 4, find f of 3. F of 3 equals 2 times 3 minus 4. And then so we multiply and get f of 3 equals 6 minus 4, and then we subtract and we get f of 3 equals 2. And then another example, given the quadratic function f of x equals 3x squared minus x plus 5, find f of 2. F of 2 equals 3 times 2 squared minus 2 plus 5. Evaluate the exponent, you get f 3 times 4 minus 2 plus 5. Multiply 3 and 4 and you get 12 minus 2 plus 5, and you simplify and you get f of 2 equals 15. An example, given the cubic function f of x equals x cubed minus 1, find f minus 1. You get f minus 1 equals minus 1 cubed minus 1. Evaluate the exponent, you get minus 1 minus 1, and do the subtraction, and you get f of minus 1 equals minus 2. And then the third example, given the absolute value function fx equals absolute value of x plus 8, find f of minus 6. So f of minus 6 equals the absolute value of minus 6 plus 8. Evaluate the absolute value, you get 6 plus 8, and then do the addition and you get f of minus 6 equals 14. All right. Operations with functions. Similar to the set of real numbers, functions can be added, subtracted, multiplied, and divided. Addition of functions. The sum of two functions, fx and gx, is defined as f plus gx equals f of x plus g of x. Let fx equals 6x plus 5 and gx equals 2x minus 1 to find f plus g of x. F plus g of x equals f of x plus g of x from the definition of the addition of functions. And then you substitute for f of x and for g of x, and then you group like terms and combine like terms. Great. Subtraction of functions. The difference of two functions f of x and g of x is defined as f minus g of x equals fx minus g of x. F of x minus g of x. Example, let f of x equals 3x squared plus 11 and g of x equals minus x squared minus 4x plus 3. Find f minus g of x. And so we subtract the functions. We substitute 3x squared plus 11 for f of x and minus x squared minus 4x plus 3 for g of x. Then we distribute the negative 1, which is the outside the g of x. And then we group like terms and we combine like terms and we get 4x squared plus 4x plus 8. Multiplication of functions. The product of two functions, f of x and g of x, is defined as f times g of x equals f of x times g of x. For example, let fx equals x plus 1 and gx equals 2x squared plus 3x minus 6. Find f times g of x. And we've got f times g of x equals fx times g of x, which is from the definition. And then we substitute the functions, and we get that expression, and then we use the distributive property. That's cool. We use the distributive property to pull the yeah, right, to pull the oh, I see. Yep. Okay, cool. Sorry. Yeah. So we distribute the x and the 1, and we get these two expressions. then we do the multiplications, then we group like terms, then we combine terms. Very good. So division of functions. The quotient of two functions, f of x and g of x, is defined as f divided by g of x equals f of x divided by g of x, where g of x doesn't equal 0. That's important. So let f of x equals 2x squared minus x minus 3, and g of x equals x plus 1, where g doesn't where x doesn't equal minus 1. So the definition of the function of division, you substitute the function expressions, then you factor the numerator, and then you can reduce the common terms, and then you can simplify where gx not equals minus 1, because that would leave the result as 0, and you're not allowed to divide by 0, which is what we did here. Cool. Graphing linear functions. Linear function is a function whose graph is a line. The solution to a linear function is the set of ordered pairs that satisfy the function. Table of values. You can use a table of values that satisfy the linear function to make a graph. For example, f of x equals half x plus 2. Make the table of values that satisfy the function. They've given minus 2, minus 4, 0, and 2, and 4, and plot the points on the coordinate plane and draw a straight line passing through them. Of course, you really only need 2 points. Slope-intercept form. A linear equation can be used to represent a linear function where y represent fx. In a linear equation, y depends on x, therefore y is the dependent variable and x is the independent variable. The solution to a linear equation is the set of ordered pairs that satisfy the equation. The slope-intercept form of a line is written y equals mx plus b, where m is the slope and b is the y-intercept. The slope of a line describes its steepness. Slope equals vertical change divided by horizontal change, also known as rise over run. The y-intercept is the point where the line intersects the y-axis. It has coordinates 0, b. For example, graph y equals 2x minus 3. The slope is 2, which is m equals 2, which is rise over run, which is 2 divided by 1. And the y-intercept is minus 3. Plot the y-intercept at the point 0, minus 3. From the y-intercept, rise 2, go up 2 and run 1. Go right up 2 and right 1. Plot another point, and then draw the straight line through the 2 points. All right. So now we're on to page 3. All right. Rational expressions and equations. Rational expression. A quotient of two polynomials. Rational expression. A quotient of two polynomials where the divisor or numerator is not 0. Simplifying rational expressions. To simplify rational expressions, factor the numerator and denominator, then remove factors of 1. Note, any rational expression with the same numerator and denominator is equivalent to 1. For example, we're going to simplify x squared plus 5x plus 4 divided by x squared plus 2x plus 1. So first you factor the numerator and the denominator, x plus 4 times x minus 1 divided by x plus 1
times x plus 1. Then factor the rational expressions. Okay. And then you've got 1 times x plus 4 divided by x plus 1, and you simplify, and you're done. I have to say I'm a little bit confused by this thing here. Factor the rational expressions. If I was solving this, I would have just cancelled the x plus 1 and the x plus 1 and gone straight to this expression. So this is something that I'm not familiar with. I don't understand. Maybe this is involved in the proof of why you can just cancel those numbers, but this divided by this is just 1, so they cancel, and I would have just cancelled them and be left with this. So I'm still a little bit confused about this factoring of the rational expressions, but I'm not going to dwell on it. Let's move on. Operations with rational expressions. Rational expressions can be multiplied, divided, added, and subtracted. Multiplication. To simplify by factoring the numerator and denominator and remove any factors of 1. Then multiply the numerator and multiply the denominators. Okay. So we're multiplying x squared plus 6x plus 8 divided by x squared plus 4x plus 3 times x plus 3 divided by x plus 2. So factor the numerator and denominator. So we turn the top into x plus 4 times x plus 2, and the bottom is x plus 3 times x plus 1 multiplied by x plus 3 divided by x plus 2. Then it says factor the rational expressions, and this is where it does that same thing that it did last time. I'm gonna have to take a break. All right, we're back. And again, it baffles me when it says factor the rational expressions. But it just instead of just canceling it rewrites them this way, and then it goes 1 times 1, and then it just left with that. I would have just cancelled those, so I'm a bit confused about that, but no problem. The important thing to know is that A times B divided by C times D is the same as A divided by C times B divided by D. Anyway, there's more to do. Division, that's going to do my head in. Rewrite as multiplication for the reciprocal by the reciprocal, then follow the same steps to multiply. Okay, so when you're dividing one rational expression by another rational expression, okay, it's so the rational expression is the quotient of two polynomials, so that's this and this. And the reciprocal just means you flip the numerator and the denominator, which is what they've done here in this example. So the left-hand side stays the same, and then the right-hand side is turned into a reciprocal by altering by flipping the top and the bottom, and that turns the division into a multiplication. Then you do the multiplication, and then it calls factoring the rational expressions, but that just basically means figuring out what we're going to cancel. And we cancel this, and we get this. And you can simplify that by removing the ones, and this is the result you get. And you could distribute that too, I guess, if you wanted to. I'm not sure what the rule is about that. Do they have a preference in the exam? I don't remember. All right, addition. Factor the denominators if necessary, and then find the lowest common denominator. Okay, so if we're adding 3 divided by 2x plus 5 divided by x, common denominator of 2x and x is 2x. Is it? Okay, well, I see what they've done here. They're just multiplying both sides by 2, which is what they do to get that and that the same. Okay. And then you do the multiplication, and you get 3 divided by 2x plus 10 divided by 2x. And then you can do the addition of the top parts, and the bottom part stays the same. Very good. Subtraction. Factor the denominators if necessary, then find the lowest common divisor. Note, when subtracting rational expressions, remember to distribute the negative sign to all the terms in the quantity that is being subtracted. All right, so the common denominator, we just take it as x times x plus 3. And then we use FOIL, which is first, outer, inner, last. First, outer, inner, last, which is how we get x squared minus x minus 12, because it's x times x. Well, sorry, it's x times x, and then minus 4x plus 3x plus minus 12. So that minus 4x and plus 3x becomes minus 1x. So we used first, outer, inner, last for that expression. And then we've got this as the common denominator, and and then we've got to re-simplify this to get it back to the form that it was in, so that we can cancel the x plus 3 and part of the thing. Is that right? Oh, no. And then once it's in this form, the denominators are common, we can just do the subtraction. So and you've got to distribute that negative correctly, which is what they said. So it's x squared minus x squared, and then you've got 0 plus x, which is x, and then you've got 0 minus 12, which is plus 12, and you get x plus 12 on x times x minus plus 3. Very good. Wow, okay. Solving rational equations. So those were rational expressions. These are rational equations. An equation that contains one or more rational expression. To solve rational equations, multiply both sides of the equation by the lowest common denominator to clear the fractions, then check the solutions. Note, when you multiply both sides of an equation by an expression, containing a variable, the result may not be an equivalent equation. The new equation may have extraneous solutions that the original does not. Oh, that's interesting. For example, solve x divided by x minus 3 equals 5 divided by x minus 3. Okay, so you multiply each side by x minus 3 and you get x equals 5. Substitute 5 for x in the original equation. And you get 5 divided by 2 equals 5 divided by 2, which means the solution is x equals 5 divided by 2. Okay. Example, solve 1 divided by x minus 1 plus 1 divided by x minus 2 equals 1 divided by x minus 1 times x minus 2. Okay, so we're going to multiply each side by x minus 1, x minus 2. This will simplify to 1. Oh man, I'm going to have to think about this one. I'll be back. All right, so we're working through this one here. We start by multiplying both sides by x minus 1 times x minus 2, and then the minus 1 and the minus 1 cancel, so you get x minus 2, and then the minus 2 and the minus 2 cancel, so you get x minus 1. And the top and the bottom are the same, so they cancel and they become 1. And then you do the additions and collect like terms, and you get 2x minus 3 equals 1, combining the like terms. Then subtract, add minus 3 to both sides, you get 2x equals 4, you get x equals 2. Then you put 2 back into the original equation. There you go. So, and then there is no solution because when x equals 2, there is a 0 in the denominator. Fascinating. All right, now we're on to radicals. Radical expression is an expression written with a radical sign, which is like the square root sign. It's called the radical sign, and you can put a number with it to indicate the exponent, I guess. The radicand is the number under the radical sign in a radical expression. I'm not sure what they call the number. It's got a term, and I read it recently, and I forget actually what it was. Square root. Let me look that up. I'll be back. All right, so what I was thinking of is the top part of the radical. The top part of the radical sign is called the vinculum. And the number outside the radical sign is called the index. So I don't know if it's going to tell us about the index in this, but we'll see. So the radical expression is an expression written with a radical sign, which is as we've discussed. And then the radicand is the number under the radical sign in a radical expression, which we already mentioned. Finding square roots. A number a is the square root of a number b if a squared equals b. A positive number b has 2 square roots, written as root b and minus root b. example, because 5 squared equals 25, minus 5 squared equals 25, the two square roots of 25 are 5 and minus 5. Principal square root is the positive square root of a number. Let a greater than 0 and b greater than 0, and the properties of square roots. So the product is that the square root of a times b equals the square root of a times the square root of b. For example, the square root of 12 equals the square root of 4 times the square root of 3. Which equals 2 times the square root of 3, because we can simplify the square root of 4 as 2. Great. And the quotient is the square root of a divided by b is the square root of a divided by the square root of b. And then they give us the example of the square root of 3 divided by 16, which equals the square root of 3 divided by the square root of 16, which equals the square root of 3 divided by 4. Simplifying square roots. A square root expression is considered simplified if no radicand has a perfect square factor other than 1, and there is no radical in the denominator. Oh, I didn't know that. Okay, so we're going to simplify the square root of 27, and we're going to get the square root of 9 times the square root of 3. Square root of 9 is 3, and that's the solution. We're going to simplify the square root of 75, which is going to be square root of 25 times the square root of 3, and simplifying you get 5 divided by the square root of 3. Now, simplify the square root of 17 divided by 64, and you get 17 divided by the square root of 17 divided by the square root of 64, using the quotient property of square roots, and you get minus 17 on 8. Very good. And then we're going to simplify the square root of 16 divided by 49. We're going to use the quotient property, and we're going to have that as 4 divided by 7. But we didn't get any examples with a radical in the denominator. The radical in the denominator. Oh, there we go, rationalizing the denominator. The process that's coming up next, so that it looks like they're going to cover it here. The process of clearing any radicals from the denominator when simplifying a radical expression is called rationalizing the denominator. To do this, multiply by 1. Form of denominator. So if the denominator is square root of a, then multiply by root a divided by root a. Okay. If the form of the denominator is a plus the square root of b, then multiply the expression by a minus b divided by a minus root of b, sorry. And if it's in the form of a minus root b, then you multiply by a plus root b divided by 8 plus root b. So if we're going to rationalize the denominator with the square root of 5 in the denominator, then we multiply by the square root of a divided by the square root of b, which is square root of 5 divided by the square root of 5. The square roots sort of annihilate each other, and you get 5, and you get on the top, you get the minus, get the square root of 5. And here it's given us another example. It looks like it's not going to give us an example of a minus b, but that's just a sign difference. So this one, we're rationalizing the denominator 3 divided by 2 plus root 7. So we multiply both sides by a minus root 7. and then we use the distributive property. And then we simplify. So this is the old first, outer, inner, last. Just yeah, right. Finding odd and even kth roots. Okay. The number c is the cube root if a cubed equals a. 2 is the cube root of 3 because 2 cubed equals 8. Minus 4 is the cube root of minus 64 because minus 4 cubed equals minus 64. Every real number has exactly one cube root in the real numbers represented by cube root of a. There are fourth roots, fifth roots, and so on. If 4a, if the how do you pronounce that? The fourth root, yeah, if the fourth root of a equals c, then c to the power of 4 equals a, and so on. In general, the number k in the kth root of 8 is called an index. There you go. So we finally learn what the term for that is. Use these rules to summarize kth roots for any real number a. The kth root of a to the power of k equals the absolute value of a when k is even, and the kth root of a to the k equals a when k is odd. For example, simplify the sixth root of 64. That's the sixth root of 2 to the power of 6. And then that's the absolute value of 2. The answer is 2. And okay, the fifth root of 243 is 3 to the power of 5. Sorry, 243 is 3 to the power of 5, so the kth root is, the fifth root is 3. All right, let me just take stock. Where are we up to? All right, we've got, we're halfway through. I think this is page, okay, hang on. We've done 1, 2, 3, 4. Okay, we're more than halfway to. We're up to page 5. We're almost finished. 5 and 6. All right, cool. So let's just confirm. Yep, we just finished radicals. Great. All right. So we're up to page 5. This is the penultimate page. We're nearly done. Okay, this is radicals continued. So properties of kth roots. Property and example. Let a and b be any non-negative numbers and k any natural number index. Then the product of the kth root of a times the kth root of b is the kth root of ab. Okay, for example, the cube root of 5 times the cube root of 2 equals the cube root of 10. And let a and b be any real numbers where b doesn't equal 0 and k is any natural number index. Then the quotient, the kth root of a divided by a, equals, I think that's supposed to say the kth root of a divided by b. Gee, that's 2 mistakes we found so far.
So it's the kth root of a divided by b equals the kth root of a divided by the kth root of b. And the example you see that the number that is just a mistake. How annoying. All right. Anyway, we know. So the cube root of 27 divided by 125 equals the cube root of 7 divided by the cube root of 125, which is 3 divided by 5. All right, so we got some more examples. Simplify the cube root of minus 64x cubed. So we can convert minus 64 to minus 4 cubed using the product property of kth roots. Okay, and then we can take the cube root of each part and we get minus 4x. Okay, and we're going to simplify the fourth root of 16x to the power of 4 divided by 81. All right. So we can rewrite that using the quotient property of kth root. So we pull the fourth root of 81. Okay. Okay. So that they've used the absolute value of x there. Did we see that earlier? I think we did. When k is even, yeah, because you can't take the square root of a negative number unless you've got I in there. Anyway, the solution is 2x on 3. Operations with radicals. Radical expressions can be multiplied, divided, added, and subtracted. For example, multiply the fourth root of 8 times the fourth root of 9. You get the fourth root of 72 using the product property of the kth roots. Multiply and simplify the cube root of 25 times the cube root of 5. So it's going to be, oh, I see, 25 times 5, 125. Simplify, you get the cube root of 5 cubed, which is 5. And then we're going to do a division. So we're going to divide the cube root of 81 divided by the cube root of 3, which is the cube root of 81 over 3, which is the cube root of 27, which is the cube root of 3 cubed, which is 3. All right. And then we're going to divide 5 times the cube root of 32 divided by the cube root of 2. Okay. So we can pull the 5 out and then change the cube root. We can put that in the radicand using the quotient property of kth roots. Then we can simplify 32 divided by 2 becomes 16. Oh, that's interesting. So you can pull the 2 cubed out and multiply by 2. That's quite interesting. So we find a perfect cube, which is 2 to the power of 3. Then we can pull the 2 out and leave that as the cube root of 2. And we get 10 times the cube root of 2 after simplifying. Very good. Addition and subtraction. Any real numbers can be added. For example, the sum of 5 and root 2 is 5 plus root 2. This sum cannot be simplified. When radical expressions have like radical terms having the same index and radicand, we can use the distributive property to simplify and combine like radical terms. For example, we can add 5 root 11 plus 3 root 11 is 5 plus 3 root 11, which is 8 root 11. Very good. And we can do the same with subtraction. So we've got 9 times the cube root of 5 minus 6 times the cube root of 5 equals 9 minus 6 times the cube root of 5 equals 3 times the cube root of 5. And, okay, we're going to add 8 times the square root of 45 plus 7 times the square root of 20. So we're going to take the square root of 5 out from the square root of 45 and the square root of 20. And then we're going to get that expression there. And then we're going to, okay, we're going to find the square root of 9 is 3. The square root of 4 is 2. We're going to simplify. We're going to get 24 times the square root of 5 plus 14 times the square root of 5. And then the radicands and the index are the same. So we can use the distributive property and combine like rational terms. And we get 38 times root 5. And then finally, subtract not. Actually, I'm just going to make more coffee. I'll be back in a sec. All right, I'm back. I don't know if that's my second or my third coffee. Probably my third. So did we just solve that? I think we did. So we're up to polynomials, I believe. I don't know if we did that one. Did we do that one? I think we did. Polynomials. Identifying by terms. Okay. So a monomial, an expression that is either a real number, a variable, or a product of real numbers and variables with whole number exponents. Oh, that's right. That's interesting. For example, 5x cubed minus 8ab y 1/4 x squared minus 9 and 4xy to the power of 4. Oh, monomial. A polynomial is a monomial or a sum of monomials. A term. Each monomial in a polynomial. For example, minus 7a squared times b. A binomial is a polynomial with exactly 2 terms. Okay, so that's 2x plus 3 as an example. And there's a trinomial, a polynomial with exactly 3 terms. For example, 4y squared plus 2y minus 1. Degrees and coefficients. The degree of a term, the sum of the exponents of the variables. The degree of a polynomial, the highest degree of the polynomial's terms. For example, identify the degree of each term of 6 times x to the power of 4 times y squared plus 4 times x times y plus 11. So to give the degree of the polynomial, the degree of 6x 4y squared is 4 plus 2 equals 6. And then the degree of 4xy is 1 plus 1, which is 2. And the degree of 11 is 0. So the degree of the polynomial is 6, which is the degree of the highest degree of the terms. Leading term, the term with the highest degree. I don't know what happens if you have like x to the power of 4 and y squared, and then x squared and y to the power of 4. I don't know. The leading coefficient. So the coefficient of the leading term. Okay. A polynomial is in standard form when its terms are in decreasing order by their degree. For example, write the polynomial in standard form. So we've got 6 times x cubed plus 4 times x to the power of 5 minus 3 plus 7x. Put it in standard form, you get 4x to the power of 5 plus 6 times 3 cubed plus 7x minus 3. The degree is 5. The leading coefficient is 4, where the polynomial is minus 12 minus 5x squared. In standard form, it's minus 5x squared plus 12. The degree is 2. The leading coefficient is minus 5. And if the polynomial is 9, then 9 equals 9x to the power of 0. Therefore, the degree is 0, and the leading coefficient is 9. Fascinating. Cool. All right, and we've got operations. Polynomials can be added and subtracted in much of the same way as real numbers. Add or subtract like terms having the same variables to the same powers. So an example of addition, we're going to add this polynomial and this polynomial. So the first polynomial is 4x cubed minus 6x squared minus 4x plus 1. And the second polynomial is 2x squared plus x minus 3. So you can just literally write the addition, and then you can group like terms. And combine like terms. So the like terms are the x squared terms and the x terms, and then you get this polynomial as the result. Subtraction, when an expression inside a set of parentheses is preceded by a negative sign, the negative sign must be distributed to each term inside the parentheses. So when we do this polynomial minus this polynomial, this negative sign needs to be distributed with minus 3x there, and minus times minus is positive, and minus times a positive is a negative, and then you group like terms and combine like terms, and you get the result. And then we're going to do the multiplication of a polynomial. Use the rule for monomial multiplication, see below, and the distributive property. So we're going to multiply 3x squared and minus x. So that's a monomial times a monomial. Use the properties of rational numbers and exponents. Right. And there's another example here. Multiply 4x and 5x squared plus 6x minus 2. So we multiply both sides, and we can use the distributive property to multiply each part, and then we can simplify and get a result. Very good. And we're up to the last page, page 6. So we're nearly there. Oh, good. So we're doing another example. We're going to multiply two polynomials here, 2x plus 5 and 7x minus 1. This is a binomial times a binomial. You use the FOIL, which is first terms, outer terms, inner terms, last terms, and you get this expression here, and then you simplify and combine like terms, and the solution is 14x squared plus 33x minus 5. And then we're going to do a polynomial by a polynomial. In fact, it's a binomial by a polynomial. And we just we have to multiply each of these by this and each of these by this. So we get 2x times x squared and 3 times x squared, and then we get 3 times x squared. Oh, I just did that. So we get 2x times x squared, and then 3 times x squared, and then 2x times 4x, and 3 times 4x, and then 2x times 5, and 3 times 5. And then we simplify and combine like terms, and the solution is 2x cubed plus 11x squared plus 22x plus 15. Division. Use cancellation of common factors, long division algorithms, or synthetic division. For example, divide 8x to the power of 5 by minus 2x squared, which is a monomial divided by a monomial. So we cancel common factors, which is so we can cancel the 2 and get 4, and the x squared and get x cubed, and the answer is minus 4x cubed. And we're going to divide 15x to the power of 5 divided by 6 times x to the power of 4 plus 18 times x to the power of 3 divided by 3x squared, which is a polynomial divided by a monomial, so we cancel common factors. So obviously we can split that up into three parts, and then we can cancel the 3 and the 15 becomes 5, and the x squared and the x to the 5 becomes x cubed, and again minus 2 times x squared and plus 6x. Very good. And we're going to divide 2x squared plus 3x plus 5 by x plus 1, which is a polynomial divided by a polynomial. Okay, using the long division algorithm. All right. So, I forget which one's called the divisor and which is called the dividend. This is the quotient, is the result. I think that's the divisor and that's the dividend. Might be the other way around. Let me check. Yeah, so where are we? Here. This bit is the dividend, this bit is the divisor, and this bit is the quotient.
I'm going to have to think about this. All right, I'm absolutely going to phone this one in because I don't get it. I forget how long division works with polynomials. I haven't been able to guess my way through. I don't understand where this 2x squared plus 2x came from. So yeah, I'm running out of time to get this video made, so I can't investigate this any further just now. So I'm just going to skip this because I don't entirely understand it. Long division I was never big on, and certainly not with polynomials. So on we go with factoring. The process of writing a polynomial as a product. To factor, 1, look for a greatest common factor, then the special polynomial forms difference of two squares, perfect square trinomial, and sum difference of two cubes. 2, look for trinomials and binomial factors, and then factor by grouping. For example, greatest common factor, 4x cubed minus 2x squared plus 6x equals 2x outside of 2x squared minus x plus 3. 2x is the greatest common factor of each term. Example, difference of two squares. So we've got a squared minus b squared equals a plus b times a minus b. So when you've got x squared minus 36, you can express it as x plus 6 times x minus 6. Example of a perfect square trinomial, where a squared plus 2ab plus b squared simplifies to a plus b squared, and a squared minus 2ab plus b squared is a minus b squared. And then did they give another example? They did. So that's 2x minus 3 squared. And the sum of two cubes, a cubed plus b cubed, equals a plus b outside of a minus ab plus b squared. X cubed plus 8 equals x plus 2 outside of x squared minus 2x plus 4. And the difference of two cubes, a cubed minus b cubed equals a minus b outside of a squared plus ab plus b squared, which is x cubed minus 27 is x minus 3 outside of x squared plus 3x plus 9. Trinomials with binomial factors. Factor a trinomial of the form ax squared plus bx plus c to equal a blank times x plus a constant times a blank times x plus a constant, where, or yeah, okay, where 1, the numbers in the first blanks of each binomial have product a, 2, the numbers in the last blanks of each polynomial have product c, and 3, the outside product and the inside products have the sum of b. With leading coefficient 1, with leading coefficient of 1, x squared plus bx plus c, where c is greater than 0. Example, x squared plus 9x plus 20 is x plus 4 times x plus 5, and x squared plus x minus 12 is x plus 4 times x minus 3. With leading coefficient that is not 1, okay, you get ax cubed plus bx plus c, where a doesn't equal 1. Okay, and you've got 3x squared plus 4x minus 15 equals 3x plus 5 and x minus 3. factor by grouping. To factor by grouping, write the original expression as the sum of two binomials and then factor each binomial separately. Write as the sum of two binomials, factor each binomial, factor out a common factor of x plus 1 in this case. All right, we're nearly done. So now we're going to solve some quadratic equations. All right, we're going to solve some quadratic equations. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a not equals 0. Factoring. Some quadratic equations can be solved by factoring the quadratic expression, then applying the zero product property. The zero product property, if ab equals 0, then a equals 0 or b equals 0. For example, if x plus 2 times x minus 1 equals 0, then x plus 2 equals 0, or x minus 1 equals 0, which means x equals minus 2 or x equals 1. For example, solve 2x squared plus 13x minus 6 equals minus 6. You add 6 to both sides and get it to equal 0, and factor it and get 2x plus 1 times x plus 6. And then you can use the zero product property to say that 2x plus 1 equals 0, or x plus 6 equals 0, which means x equals negative a half or x equals minus 6, solving for x. So the solution is minus a half or minus 6. Graphing. Another way to solve a quadratic equation is graphically. The graph of a quadratic equation is a parabola, which is relatively U-shaped or upside down U-shaped. The roots or solutions of the quadratic equation are the x-intercepts of the graph. A quadratic equation has two real roots if its graph has two x-intercepts, one real root if its graph has one x-intercept, and no real roots if its graph has no x-intercepts. For example, solve x squared minus 2x minus 3 equals 0. Start by making a table of values that satisfy the equation, then plot the points and draw a smooth curve passing through them. So we've got minus 2 and 5. And we've got minus 1 and 0, and we've got 0 and minus 3, and 1 and minus 4, and 2 at minus 3. Wow, that's neat. The solutions are where the graph intersects the x-axis. So the solutions are x equals minus 1 and x equals 3. Square roots. Quadratic equations in the form ax squared equals c can be solved by finding square roots. So we've got 2x squared minus 162 equals 0. We can add 162 to each side, and we get ax squared equals 162. We can divide both sides by 2, and we get x squared equals 81. And then we can solve for x, and we get x equals plus or minus 9. So the solutions are 9 and minus 9. And then there's completing the square. Use this method when a quadratic expression is not factorable and cannot be solved by finding square roots. Rewrite the equation so that it can be solved by square roots. The leading coefficient is 1. To complete the square for the expression ax squared plus bx, add b on 2 squared, which is the square of half the coefficient of x. Half the coefficient of x, so it's b on 2. So we're going to do an example. We're going to solve x squared plus 10x plus 23 equals 0 by completing the square. So we start with the original equation, and then we take the 23 to this side, so subtract 23 from both sides. All right, and now we're going to complete the square by adding half of b squared, which is 25. Half of b is 5, and 5 squared is 25. So that's there. Great. So we're completing the square. We add 25 both sides. Then we can turn this into a square, and then we can simplify. And we get x equals -5 plus or minus the square root of 2. And the solutions are -5 plus root 2 and -5 minus root 2. Great. So completing the square when the leading coefficient is 1, and we're going to do completing the square when the leading coefficient is not 1. If the leading coefficient is not 1, divide each side of the equation by the leading coefficient before adding b on 2 squared to each side to complete the square. So in this example, we've got 4 as the leading coefficient, which is not 1, but 4x squared plus 12x minus 7 equals 0. So we're going to start with the original equation, then we're going to divide each side by 4. So we divide this term by 4, we get 3x, and we divide this term by 4, and we get -7 on 4. And then we add -7 on 4 to each side, and we get this. And then we complete the square, and then we factor and simplify, and the solutions are x equals 1/2 and x equals -7 on 2. And here's the good old quadratic formula. So the quadratic formula was derived from taking the standard form of the quadratic equation ax squared plus bx plus c equals 0 and solving it by completing the square. That's how we get the quadratic formula. Cool. The solutions of a quadratic equation in the general form are ax squared plus bx plus c equals 0 and a not equals 0, where x equals -b plus or minus the square root of b squared minus 4ac over 2a. And that's why the a can't be 0, because if it was, that would be divided by 0 error. So solve 3x squared plus 5x minus 1 using the quadratic formula. So a is 3, b is 5, c is 1. So x equals -5 plus or minus the square root of 5 squared minus 4 times 3 times 1 divided by 2 times 3, which equals this, which simplifies. And the solutions are x equals -5 plus root 13 on 6 and x equals -5 minus root 13 on 6. Note, any quadratic equation can be solved by completing the square or using the quadratic formula. Kick ass! So we made it. This is our second one. It's all done. I'll throw you the farewell cam. We'll wrap up. And that's a wrap. So it's pretty good. I honestly, I haven't done elementary algebra since like high school. For me, this is going back like 20 years. There was some parts of this that I didn't understand. What did I not understand? That long division stuff. That defeated me. I really didn't understand that at all. So I should not be lazy. I should try and think clearly about it, and learn about how you can divide polynomials using long division. So I think I need some help with that. Everything else I understood, except I was a bit confused about the way they handled some of the factoring. They, like when you've got a divided by b times c divided by d, You can rewrite that as AC times BD, AC on BD. Just multiply the top bits and the bottom bits. Anyway, I didn't completely understand why they didn't just cancel those straight away. They refactored them and then cancelled them, which is something I would ordinarily have just done in one step. So I didn't kind of appreciate what they were doing. But as I think about it now, it kind of does make sense. I can understand that. So really the only thing I didn't understand was that long division of polynomials. Of course, the quadratic formula I remember. I didn't remember that the quadratic formula is simply the result of completing the square with a, b, and c left as variables. Anyway, we're done. So that's the end of this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.